Hello all, welcome to ML Industry. Today we are going to discuss two important topics in machine learning that are bias and variance. So we will cover the following topics in this video. What is bias? What is variance? And what is the bias variance trade-off? Okay, so let's start with the bias. Bias in machine learning refers to the error that occurs when a model makes overly simplistic assumption about the data it is being trained on. Okay, so it is essentially the difference between the average prediction of the model and the true value of the data. For example, suppose we have a data set of students with their hours of study and the scores, and we want to build a model that predicts a student's score based on the amount of time they studied, and the data may look like this. Okay, if we use a linear regression model to make predictions, the model may assume that the relationship between the study time and test score is a simple straight line, and with that assumption we train the model, and let's say we train the model like this. So now you see the line does not fit the training data points accurately. That means it actually simplifies the relationship between hours of study and score and creates a straight line relationship between them. Doing so, it allows certain amount of error while training. Now let's try to test it with this data point. Now in this case, hour of study is 10. And if we pass the data through the model, it will give a predicted score of 80, but the actual score of the data is 90. So the error between predicted and actual value is 10. This is what we call bias. Now if we calculate the average difference between all the predicted and actual output, we will get the overall bias of the model. Okay, so I hope you have got a clear idea of what bias is. Now let's see what is variance. Now, you may think variance as just opposite of bias. That is, it refers to the error when the model is too complex and tries to capture all the details, noise and random fluctuation in training data. And as a result, it tries to fit all the training data too accurately and create a very complex model, which eventually leads to poor performance on new unseen data. Let's understand with the same example we just saw. Let's say we have the same data set, and this time instead of a simple straight line, we made a really complex line which fits all the training data with no allowed error, and it looks like this. Okay, now that we have our model, let's try to test it on a unseen data point. Okay, so here is my data point, and the hour of study in this case is 9. And if we try to predict the score for this point with our new complex model, it will give a predicted output of 85. Whereas the actual value of this data, as we can see, is 60. So we have a error of 25. Now, mind you, although the model fits all the training data really well, it fails with this unseen data. This is when we call the model as high variance. So it performs really well with the training data, but because it is accurately predicting all the training data, the model is too complex to perform on unseen data. So this is what is variance is. So I hope you have a clear picture. So as we can see, neither high bias or high variance is good for any model. So a good model should have both low bias and low variance. And this is achieved by bias variance trade-off. So the goal of a machine learning model is to generalize well on new unseen data. The trick here is to train the model such a way the error between actual and predicted value is lowest and almost consistent over any given input. So if we have a consistent error, we can handle that error. So although at times simple model with high bias but low variance may suitable for some problems, while a more complex model with low bias but high variance may appropriate for some other problems. So the trade-off really depends on the problem in hand and how much detailed relation in the data we want to capture through the model. So if we take the same example, a good bias variance trade-off may result like this. This model has captured the underlying relationship of the data without really trying to fit all the training data points. So in this case, the error will be minimum for any given data point following the same relation, and also the model generalizes the relationship of the data so we can trust the consistency of the model. Hence, just giving it a little bit of bias and reducing the variance, we have got this good model. So that gives the steady predictions on any new unseen data. So this is the result of bias variance trade-off we just made. I hope you have a clear idea now what is bias variance and bias variance trade-off. And this is it from this video. If you found this video useful, please like and share with others. And if you are new to this channel, please subscribe for more such exciting videos. Thank you. I see you on the next video. Till then, happy learning.